So, okay guys, here we go for the next little block on projectiles. I'm going to look at example 8 now, and then hopefully example 9 will follow shortly. And I've switched to gadget the other way round, and hopefully that'll look slightly better on the screen while you're working. Let me know how it appears. So, a particle is projected from a point O with speed 35 meters per second at an angle of elevation of 30 degrees. The particle moves freely under gravity. Find the length of time for which the particle is 15 meters or more above zero. So let's just pick out again the crucial facts in the question. Projected from a point 0, a speed of 35 meters per second, angle of elevation of 30 degrees, angle of elevation being above the horizontal. The particle moves freely under gravity. Find the length of time, so it's the time we want, which the particle is 15 meters or more above zero. Okay, let's have a little sketch of that then. So, we're projected at 35 meters per second. It's an angle of 30 degrees. And we want the time at which it's above 15 meters. So there's going to be a couple of occasions where it's 15 meters above the ground. So if we list out the key facts, well, before we do that, we're going to recognize that it's constant acceleration because we're not given anything as a function of t. We're going to work vertically. And u then is going to be equal to, let's break this force down, this speed into its components then. Horizontally, we've got 35 cos 30, because that's adjacent to the angle. And then we've got 35 sine 30. So our u value is 35 sine of 30 degrees, which is our vertical component. So that's our vertical component that we've got there. Then we've also got A, which is equal to negative G as it's acting downwards. We've got S equals to 15, and we want something to do with the time. Look at the equation, U, A, S and T. That suggests we're going to need to state S equals UT plus a half AT squared. Then we can substitute in. S is equal to 15. Whoops, change the colour back. S equals 15 equals U, which is 35 sine of 30. T plus a half G, acceleration which is minus G, T squared. So now we can solve that. And we get 15 equals 35. Sine of 30 is a half. T minus GT squared over 2. Set up the quadratic and we'll get GT squared over 2 minus 35T over 2 plus 15 equals 0. Now in the modern exams, unless it says show that, you can tap it in the calculator and out comes your two values for t. So t is equal to 10 sevenths and 15 sevenths. So since it's come out as fractions, we should have been able to factorise that if it had said show that. Okay, now then, we want the time of height. Now, as usual, go back, read the question. So we've done all that work. We think, well, have I actually answered what was asked? And it says, find the length of time of the particle is 15 metres or more above zero. So the time above zero then, so time above 15 metres equals the difference in their time. So 15 over 7 minus 10 over 7, which is 5 sevenths of a second. Okay, I will record the second one shortly, and then hopefully I'll get those put up.